Today I'm going to explain matrix transformations, which is part of your syllabus D for school certificate O-level. And let's begin with, for instance, reflection. We talk about reflection now in the, let's say, x-axis. Reflection in the x-axis. Now suppose you've got a square here, and this point is 1, 0, this one is 0, 1, and I tell you to reflect this in the x-axis. Of course, if this is reflected here, it's going to come down here. So the 1, 0, which is on the x-axis, will remain there as 1, 0, because that's not going to reflect, it's going to stay there. As if this is the mirror line, so this point is going to stay there. However, that point which is 0, 1 is going to become 0, minus 1. So then 0, 1 is going to reflect onto 0, minus 1. Now the resulting matrix is this and that. Therefore, the matrix for reflection in the x-axis will be given by 1, 0, 0, minus 1. So in other words, what we're saying that this matrix will be used if you have to do a reflection in the x-axis. For instance, let me just give you a very simple example. Say A, which is 2, 1, is reflected in the x-axis. Find its image. Okay, so then what we do, we just take the matrix, which is 1, 0, 0, minus 1, times the coordinates, which just put the coordinate as a column vector, 2, 1, and if you were to do this, you're going to get 1 times 2 is 2, and this is minus 1. So the answer is 2 minus 1. You can directly say 2 minus 1, because you know that this point is going to remain the same, 1, 1. So the 2 remains, but if you forget in the exams, but it's very important that you remember how to do it by matrix, because that's what they're going to ask you. Let's talk about reflection in the y-axis now. Reflection in the y-axis. Okay. Reflection in the y-axis. Similarly, if you have your coordinate axis, this is the y-axis, this is the x-axis, you may have a square here, and this is 1, 0, and it is reflected in the other side. Here, this is your mirror line, and now this becomes minus 1, 0. And this remains there as 0, 1. So we look for x first. This one is reflected. So 1, 0 goes on to minus 1, 0. And then at the same time, 0, 1 remains invariant. It doesn't change. So the resulting matrix of these, then you've got minus 1, 0, 0, minus 1. So this is how you pull the matrix for reflection in the y-axis. Okay. Now suppose you've got, let's say, your x and y axis like this, and you've got the line, let's say, no, there's no line here, sorry. Let's say this is the line x is equal to h, and you've got a point here a, b, and I tell you this point is reflected into this line. What its image is going to be in the other side. So we use the formula, so it's reflected in the line x is equal to h. The height here remains the same. Like, you know, let's, for example, if you were standing here, okay, and then you look at yourself in this mirror, you will see yourself there. So your height will be the same. That means the y remains the same. So b is the same. But the problem with the a is going to change into 2h minus a. That's the formula. So what we're saying is that AB is reflected in the line x is equal to h is mapped onto its image, which is 2h minus a and then b. Alright, so this is reflection in the line x is equal to h. You may be given a question like this. Let's say the point, okay, 2, 1 is reflected in the line, say for instance now x is equal to minus 1, okay, find its image. So that's not very difficult. What you should do, just use this formula. Therefore we're going to say 2, 1 is going to become 2h, that is 2 times the line of reflection, minus a, and therefore you minus the 2, and then your y is going to remain the same, and so that becomes then minus 2 minus this is going to be minus 4, and then 1. Here we are, that's the image. We're going to look at reflection in the line y, so x equal to h, now y is equal to k. Let's say for instance you've got your coordinate axis like this, and you've got a line somewhere here, and this is the line y is equal to k. So this is your x-axis, and that's your y-axis. Now you've got the point A and B, and that point is reflected into this mirror line and goes into the other side. So AB reflected in the line y is equal to k is going to become, now as you can see, the x coordinate will remain the same at any point. So we're going to have A, it's the opposite of the line x is equal to h, and this is 2k minus b. There we go. I don't think there is any need for me to take an example here because it's just very straightforward. You're going to have to remember this in the exams in case you need it. Alright. The other thing that concerns matrix in transformation is rotation. Now let's talk about rotation. For instance, you may have an anti-clockwise rotation of 90 degrees with the origin, we're talking about origin. Origin is 0, 0. Alright. And you have a square here, this is your x-axis and this is your y-axis. In this now, I'm gonna show you how you pull the matrix out. There's no need for you to remember the matrix by heart in exams. Well, if you remember and your memory is that good, then that's okay. However, this is a very smart way of remembering, of bringing the matrix back if you, in case you've forgotten. There's a point 1, 0 here, and there's the point 0, 1 over here. Now I tell you that this thing, this square here is rotated. It's rotated and falls onto this square here. I'm sorry, it's a bit bigger. So the 1, 0 is rotated. It goes there. So the 1, 0 rotates 90 degrees anti-clockwise. Okay, so this is anti-clockwise. Okay, and then it falls onto 0, 1. So that's the resulting image. So this is what we need. Now then the next thing that happens, this point itself now is rotated and falls back on and falls onto this point here. Falls here. So minus 1, 0. Therefore 0, 1 is now rotated 90 degrees. I'm going to say minus 90 because that's anti-clockwise, and then it falls onto minus 1, 0. So your matrix for rotation of 90 degrees, matrix for anti-clockwise 90 degrees about the origin, okay, about O is then 0, 1 minus 1, 0. Okay, so if you are given a triangle and the triangle is rotated, let's say for example a triangle is here and I tell you that this triangle is rotated 90 degrees. Triangle is rotated 90 degrees anti-clockwise. What its image is going to be about O, that's very important, about O, for the origin, what its image is going to be. Now what you should do, you just take that matrix 1 0 minus 1 0, sorry, 0 1 minus 1 0, and you multiply by all the coordinates of A and B, I mean of the triangle. So you might have coordinates A here, coordinates B here, coordinates C here. Alright, so you multiply by coordinate A, B and C. Let's say the coordinates are X, Y, let's say A, B, let's say D, C. Alright, and then you're going to get the image of each of these coordinates. Once you get each of these coordinates, then you plot the coordinates, and of course this is going to rotate 90 degrees about O. It may rotate and fall somewhere there. Alright, so this is how we do it. Okay, I'm sure you understand. Alright, so this is 90 degrees rotation anti-clockwise. In a similar fashion, we are going to look at hang on here, paper won't need it anymore, so right, I'm going to look at rotation anti-clockwise and clockwise for 180 degrees. Okay, now 180 degrees, remember this has rotated 90 degrees, it's fallen here. Now another 90 degrees, it's going to fall down here. So we're looking at plus or minus 180 degrees rotation about O. Okay, so what is going to happen now, you look at the X first, so this one's going to fall here, and then this one's going to fall there. That's rotation. In other words, we're saying that this here has gone all the way here. So this thing here, it has rotated, it's come down, and that's the image. Let me just write image here. Okay, so what are we saying is that the X, okay, the X-axis, alright, hang on a second. Therefore, we're looking at this point here rotating, alright, and falling onto this point. So this is like 1 0 falling onto minus 1 0. So 1 0 is going on to minus 1 0. That's the image. And also we've got this one rotating on coming down here. So 0 1 going on to 0 minus 1. Therefore the resulting matrix is going to be equal to minus 1 0 0 minus 1. You can test for any points and rotate and use the matrix, and you will see it does add up. Now let's look at rotation of 270 degrees anti-clockwise. So now we're looking at 270 degrees. So your square is here originally, and this is the X point, which is 1 0. Now this point 1 0 will rotate 270 degrees. So I'm going to rotate this 270 degrees. 90, 180, 270. So it's going to fall back down here. Right, so it's going to fall here. So this point is rotating and falling here 270 degrees. So this is 0 minus 1. So we've got 0 minus 1. And of course now this point here also is going to rotate 270 degrees. So 90 falls back down here, it falls down here, 90 degrees falls down here, another 90, that makes 270, it falls over there. So 1 0. So 0 1 becomes 1 0, and your resulted matrix is now 0 minus 1 1 0. So here we are. This is matrix for rotation 270 degrees anti-clockwise. Okay, let's talk about for instance, if you have an enlargement, and we're talking about enlargement about origin, about O. You may have a figure like this, for instance, and then there's enlargement about the center. Let's see, like this, and then this becomes there, a big one. Okay, so that's an enlargement. All right. Of course, if this is O, and this has a certain size, you have to take the size of each of these sides, multiply by a constant k to result to get this one. So matrix for enlargement about O, where the scale factor is the number by which you multiply the size of the original figure to be able to get its image, the size of its image. So where the scale factor is k, therefore the matrix is going to be 0 k, k0 0 k. Alright, so you may be given something like this. Okay, if the scale factor is 2, then the matrix that you will use throughout the transformation will be 2002 for your enlargement. Okay, so you can get a question where there is a coordinate A and the coordinate is 2 1, and I tell you there is an enlargement, and I tell you that the center is 0 0, therefore the image will become 202, so 2002 times the point, which is 2 1, and then you're going to result, this is going to result into 4 2. Here we are. This is how you do enlargement scale with a scale factor k and center 0 0. Now we're going to look at the matrix for, say for instance, just one moment please. Alright, so the next part is now we're going to look at shear. So a shear with the x-axis, shear with the x-axis. The matrix is basically 1 k 0 1. So what I mean by that, if you get a shear in the exams, you have to use the shear factor will be given. You may have a shear, like say for instance, a shear with the x-axis will look something like this. Say for instance you got a square here, and you shear with the x-axis. This is the x-axis, so along the x-axis it's going to become like this. Alright, so that's your shear with the x-axis. This is the image of that square. Okay, so let's say the point 2 1 is, all it undergoes is sheared. Alright, with or along the x-axis. Find its image. So we're going to use a matrix. This is your matrix. So the image is going to be equal to, is shared with, given that the scale factor, or the shear factor for that matter, more appropriately, shear factor is 3. So how are you going to find its image? Therefore the matrix is 1k, so 1 3, because here we are, the shear factor is 3 0 1, and then you multiply by the point, the coordinate 2 1, and you get its image. So this is the image, 1 times 2 is 2, 1 times 3 is 3, 3 plus 2 is 5, 0, 1. So you got image, let me just call it I, the image is 5, 1. Okay, you may also have a shear with the, say, y-axis. For a shear with the y-axis, let's say the square is here, so this will be your image. This is a shear with the y-axis. X-axis is here. And for shear with the y-axis, the matrix is going to be equal to 1k, 0, 1. Hence, if you have, let's say, the same, or maybe a different point, let's say the point x is 1, 5, and this is the shear factor. Shear factor is, let's say shear factor is -2, or I don't know why I put this in brackets here, but it's -2. Okay, find x dash, its image. So again, what you're going to do, you can use the matrix 1k, and k is -2, 0, 1, times the coordinates, which is 1, 5. 1 times 1 is 1, 0 times 5 is 0, 0 plus 1 is 1, and then here row times column, so -2 times 1 is -2, 5 times 1 is 5, 5 minus 2 is 3, and hence the answer is going to be x dash, which is 1 and 3. Here we are. This is how we use matrices in different types of transformations. So in this video we've covered rotation, reflection, shear, enlargement. So I'm going to write this here, rotation, okay, it was reflection first, okay, never mind, the order doesn't matter, enlargement, shear. And when it comes to reflection, there was different types of reflection, different types of enlargement, etc., etc. Okay. Now, the other thing that's very important as well is you will come across a situation where you can get, let's say, a rotation, but the center is not 0. If you get a rotation, but center is not the origin. Center is, let's say, K and then M. How are you going to do a rotation like this? Let's, for instance, if I give you a rotation, I'm just going to give an example, alright? Let's just say the point A, 2, 1 is rotated anti-clockwise 90 degrees. About, but this time not the origin, about, let's say, 5, 3. Okay, so, and I tell you to find its image. Find its image under this rotation. Okay, so how are we going to do this? Well, we can imagine on a graph how this is going to look like. You've got your point 2, 1. Let's say 2, 1 is somewhere here, and that's the point A. This point will rotate about this center. The center is 5, 3. 4, let's say 5 is here, and let's say 3 is somewhere there. So 3. So this is your center. Now the center is not the origin. So this is the point, and this is going to rotate anti-clockwise 90 degrees. Of course, it's going to fall somewhere over here. So the ending point will be somewhere there. I don't know, maybe here in this quadrant, maybe there, we don't know yet. But we know it's going to rotate 90 degrees like this. Now this sounds very difficult, but it's not. All you need to remember is that image is equal to matrix multiply by the point, take away the center, and then add the center again. So let's do for this one. So matrix multiplied by point. What's the matrix for 90 degrees? Remember we told you if this is 1, 0, it's rotating 90 degrees, it's going to fall here on 0, 1, and then 0, 1, okay, this is the x and the y is 0, 1, rotates 90 degrees, falls here, it becomes minus 1, 0. So now you pull out the matrix. You see, I didn't try to remember this by heart. Okay, 1, 0 falls onto it. Here, 90 degrees and then 90 degrees. Okay, it's not 180. This is 90 degrees. Okay, it's like this. Okay, and this falls here. 90 degrees. Right, so the matrix is 0, 1, minus 1, 0. The point minus the center, what is the point? Is 2, 1. So you're going to take 2, 1 minus the center is 5, 3. Then you take the matrix multiplied by point minus center. This is the point minus center, that's your matrix, and you're going to get your image. Then you finally add the center again. And here is the image, final image. So let's read part by part, bit by bit. Minus 1, 0, okay, times point minus center, 2 minus 5 is minus 3, 1 minus 3 is minus 2. Then you are going to add the center later on. After you've performed the multiplication, this follows the order of BODMAS. 0 times minus 3 is 0, minus 1 times minus 2 is 2, 1 times minus 3 is minus 3, 0 times minus 2 is 0, 0 plus minus 3 is minus 3. Finally, you add 5 and 3, the final image is going to be equal to 7 and then 0. So what we see that this is falling here like 7, 0. If you draw a graph, you will see it's exactly 90 degrees. If you rotate it, if you illustrate it on a graph, you will see that this point here will rotate exactly 90 degrees and fall here. Anyway, so the answer to the question is then 7, 0. That's your answer. Okay, that's about it for matrices, matrix transformations. I hope this video helps.